This is the second example. In this example, we will solve for the constants. These are the initial conditions. Initial conditions. And what we're going to do, alright, so over here on the right, I've written a note. I'm not sure if you can see that, but what I've said is that if we have two roots of lambda, then I've written out what the solution will be for one root and for complex roots. So there's that. Here's the actual equation. So it's y double dash plus 3y dash minus 10y is equal to 0. So I'm pretty sure you know what to do by now. So lambda squared plus 3 lambda minus 10 is equal to 0. This factorizes to lambda plus 5, lambda minus 2 is equal to 0. Lambda 1 equals minus 5, lambda 2 is equal to 2. We have two solutions of lambda, so because we have two roots, this is our solution. So y equals a e to the minus 5x plus b e to the 2x. Let's plug in our initial condition. Y sub 0 is equal to 4. So 4 equals a e to the minus 5 times 0 plus b e to the 2 times 0. So we know that this is going to go to 1. So 4 is equal to a plus b. Now, we only have one equation, so we can't solve for the constants. So here's the best part. We use our second initial condition. Y dash of 0 is equal to minus 2. So if we know that y is equal to a e to the minus 5x plus b e to the 2x, we take the derivative of that. So y dash equals, what's the derivative of a e to the minus 5x? Well, that's minus 5a e to the minus 5x plus, what's the derivative of b e to the 2x? That's 2b e to the 2x. Now let's plug in our initial conditions again. So y dash of 0 is equal to minus 2. So minus 2 is equal to minus 5. We know that because this is going to go to 0, this is going to go to 0, so this goes to 1, this goes to 1. So minus 5a plus 2b. That's our solution. So now we have two equations. I'm not sure, yeah, you can see that. We have two equations now, so we have to use simultaneous equations. So equation 1, a is equal to 4 minus b. So what I've done here is I've just rearranged this equation. And 2, 5a is equal to 2b plus 2. I am going to plug in this into this. So 5a, but a is 4 minus b. So 4 minus b is equal to 2b plus 2. If that's true, then 20 minus 5b equals 2b plus 2. I'll take this across, so it's negative 2b, so it's negative 7b equals, I'm going to take the 20 across as well, so 2 minus 18, so that's minus, you know the answer, minus 18. Negatives on both sides, so it becomes positive. 7b equals 18, therefore b is equal to 18 over 7. Now we can solve for a. So we know that b is equal to 18 over 7, then we use our first equation again, so a is equal to 4 minus 18 over 7. So we use lowest common denominators, so a is equal to 28, that's a minus sign, minus 18 over 7. So a is equal to 10/7. now we use because we know the constants, we can finally finish the equation. So therefore y is equal to 10/7 e to the minus 5x plus 18/7 e to the 2x. And that is our solution. And that's how you solve second order differential equations and solve for the constants. All you have to do is remember to plug in your initial conditions, and obviously because that'll only give you one equation, if you plug in one initial condition, you have to take the derivative of that equation and then plug in the initial conditions. And that's how you get the solution.